Hello, today we'll see the circuit full adder. Now this is a circuit which will add two binary bits, this A, B, along with the carry which is generated in the previous column of addition, and it generates two outputs, one is sum and carry. Now what is this carry generated in the previous column? I will just give you one example. Suppose I have two bits, 2-bit binary number. Suppose I am adding 0 1 plus, let us say, 1 1. Just one example I am giving. So how I will do binary addition? 1 plus 1, I know it is 0 and carry comes over here. Now when I am adding this next bits 0 and 1, this carry I need to consider. So in order to do that, this is nothing but bit A, this is nothing but bit B, and this one which is generated in the previous column is called as a CI. And now to do all this addition, all these 3 bits I have to add now. For this I need a circuit which is called as a full adder. For addition of these 2 bits, plain bits, we can use a half adder. We have seen that in the last video. So to add these 2 binary bits along with this carry which is generated in the previous column, we need the circuit full adder. So now we have to make the truth table for this. So truth table means it's a table which includes inputs and outputs. So as 3 inputs are there, naturally the combinations will be 8. So all the 8 combinations I have written already. So my inputs are A, B and CI. What may be the combinations now? As why 8 combinations are there? As it is a 3 bits, 2 raised to 3. Again, why 2 is the base? Because it is binary. So 2 raised to 3 is 8. So 8 combinations are done. So see the combinations: 0 0 0, next is 0 0 1. Similarly till here, last is 1 1 1. These many combinations are possible. That's why 8 combinations are shown in the table. Now this is the input. For outputs, now what outputs it is generating? Sum and carry. Now it is a plain binary addition we have to do and write. So if it is 0 0 0, naturally the sum will be 0, carry also will be 0. When it is 0 0 1, the addition will be 1, there is no carry, so 0. If it is 0 1 0, again sum will be 1, carry is 0. So like that all combinations are done. If it is 1 1 1, as per binary addition rules, we know that sum is also 1, carry is also 1, because if it is triple 1, output comes or the result comes 1 plus 1 is actually 0, carry 1. Now in that you are adding one more bit over here. That's why this is sum is also 1 and here carry comes as it is down. So carry is also 1. And that's why here when it is 1 1 1, your sum is high, logic high, and carry is also high. So this is the table we have done. Now we have to design the circuit which will do this. So design means now we have to write the sum of product equation for the sum as well as for the carry. Then we will solve that equation and then we'll come to know which gates we need to use. So that sum of product equation, or we call it as a SOP equation, for sum now I have to do. So I have circled the outputs where I am getting output high. So I am getting output high 4 times here: 1 2 3 4. So I got 4 terms. So those 4 terms I have written. I hope this is clear that for this for this one I have written the term A bar, B bar and CI. Why it is? Because A is 0, that's why A bar. B is 0, so B bar. CI is as it is because it is already high. So the term is A bar, B bar, CI. Similarly, the remaining 3 terms are written: A bar, B, CI bar plus A, B bar, CI bar plus AB, CI. Now if I solve it further, I could see here I will combine these 2 terms. In this I will take common A bar. So what will come inside? B bar CI plus B CI bar plus In this now I will take A common. What comes inside is B bar Ci bar plus BCi. Now if I see this bracket, this is nothing but the logic boolean expression of XOR gate. So I can write here A bar B XOR Ci plus this bracket. If I see, this is nothing but the boolean expression of XNOR gate. So this bracket will be replaced by B XNOR Ci. Now if I could see this equation here, B XOR Ci is common. So I am assuming it as a X. So if I assume this as a X, my equation will become A bar X plus AX bar. That means this is nothing but again a XOR gate equation only. So this equation can be written as A XOR X. But who is X? X is nothing but B XOR Ci. So this X will be replaced by B XOR Ci, and so therefore the equation for the sum will come A XOR B XOR Ci. That means to generate this column sum, if I use a XOR gate and if I do A XOR B XOR C, this column is generated. Now we'll see it on the breadboard ki which gates I need to use this and all. Let me complete first this truth table part. So for the carry now we have to do carry also. How many times it is high? 1 2 3 4. I have circled those things. Now again I have to write the product terms for all those 4. So this equation I have kept ready. So thus see here the first term I will let me explain for this. This is nothing but the corresponding term is, this is A, this is 0, this is 1, this is 1. That time you have got carry 1. That means this term is nothing but A bar B Ci. So the same thing I have written here, A bar B Ci. Remaining 3 terms I have listed A B bar Ci plus A B Ci bar plus A B Ci. Now in this also, in these first 2 terms I will take Ci common. If I take Ci common, this is A bar B will remain in the bracket plus AB bar plus in these 2 terms I am taking AB common. If I take AB common, what goes inside the bracket? Ci bar plus Ci. Now this equation boolean expression is of XOR gate. So this bracket will be replaced by A XOR B plus AB, while as per boolean algebra rules Ci bar plus Ci is nothing but 1. So this bracket is vanished. So what remains for the carry? The equation is Ci A XOR B plus AB. So these are the 2 equations we got. Now I have to use for the sum, I have to use here just a plain XOR gate, and for this I have to use XOR here and gate I have to use for this expression, and as it is, this is the plus, I need to use a OR gate also, and here also as it is Ci dot A dot B, I have to use here also one AND gate. That means I need to use here one AND gate for this combination, one XOR for this combination, and for this combination, and for this I have to use one OR gate. That means these many gates I need to use. So what will be my hardware if I have to draw the hardware? Will be this. See here, this is XOR gate. Now 3 input XOR gate we are not using. I am using 2 input OR XOR gates only. So my this is A B will go to one IC which is 7486. The ICs I have explained in the half adder video. So there you can refer. These are the ICs. I just show you this. These are the ICs 7486. Internal circuit is like this. 4 gates are there. One of them you can use. The combination is 1 2 3. I am using here for XOR. Then for the OR gate is 7432. OR gate inside the structure is also same like this only. In this only I am using this combination 1 2 3. Similarly this is 7408. Internal diagram is like this, and again I am using the first gate only. So the combination is 1 2 and 3. So in this way the gates internal diagrams are there. Now look at this circuit diagram now. Here is a XOR gate used. 1 and 2 is the pin numbers as I have shown you just now. This is the third output, that is it generates A XOR B. Now that is going ahead with another 7486 because we have to generate A XOR B XOR CI. So this pin number 5 is nothing but CI. So this upper part will generate some expression, that is A XOR B XOR C. Similarly, as we got this expression as for the carry, we got the expression as CI into A XOR B. So what I have to use? I have to use the AND gate. So A XOR B, I have tapped the points from here only. CI is nothing but this. So these 2 points will generate one expression, that is CI A XOR B. And then the later part over here is AB only. So AB means I will tap A point from here, B point from here, and I have got the another AND gate and I have generated AB. Now further this has to be added, that's why I require a OR gate. So these two outputs are given to the OR gate and it has generated a carry, and that equation what is generated will be CI dot A XOR B plus AB. So this is nothing but the circuit diagram. Now we will see that we will mount it on the breadboard because we are learning the practical circuit of the full adder. So we will mount the circuit on the breadboard. So on the breadboard I have already mounted the circuit. You can see the circuit over here. I will just tell you which IC is what. This is 7486, which I have told you ki I am using it for the generation of the sum. So this is 7486, that is XOR gate. This is 7408, that is AND gate, and this is OR gate 7432. Now the same circuit is mounted over here as per the pin diagram. So I will just show you. This is my power supply. So this positive is connected over here on the breadboard on top, and the negative, this black wire, I have connected to this line. So my this full line is working as a ground, down one, and the full upper line is working as a plus. Now breadboard connection, you all are aware that pin number 14 of each IC has to be connected to the positive of the power supply. So this is positive, and ground for this is the black wire. This is connected to the ground. This is also ground, and this is also ground. So these black lines are connected to the ground, while these upper red are connected to the positive of the power supply. So these are the basic power supply connections. By referring the pin diagram 1, 2, 3, then 3 and 4 has to be shorted and all. So all these connections are done over here. If you see 4 and 5 is shorted. This small wire you can see, that is 4 and 5 is shorted. This green one is A, this is B, and this black one is C. See here, A, B and C. So these are my 3 lines. Then for the sum, this is the resistor, current limiting resistor is used because I am connecting LED over here. So I need a current limiting resistor in series with that. So this LED is for showing the sum output, while this LED along with the resistor again in series is showing for the carry output. Now we will check the truth table whether it is working as per our truth table, whether the circuit is working as per this. So I will show you the few combinations and we'll see whether it works. So I will put down the power supply now. Now if I see here, the sum LED is glowing, carry LED is glowing, and if you see that all the outputs are open. Now these are the outputs. Logic, when these inputs are high, I mean when they are open, I have not connected anywhere, they act as high. That means actually my condition in this truth table is 1 1 1. A is also 1, B is also 1, CI is also 1. I expect sum should be high and carry also should be high, and I am getting that sum is high, carry is also high. Now we'll check some other combination. Let me check this 1 1 0 combination. So 110 means I have to make this CI bit, I have to make it ground. So where is CI bit? CI bit is nothing but this black one. So this I am connecting it to the ground. Ground means I have to connect it to the this down line of the power supply. So if I do that, you can see here, A is high, B is high, CI is grounded, and my sum output is high. See here in the truth table, sorry, sum is low. Yes, sum is low and carry should be high. So see again, sum is low, carry is high. Yes. So I have tested this was working fine. This is also working fine. Any other combination will test. Let us say 1 0 1 I will check. That means B I have to make it ground. So B I have to make it ground. Who is B in this now? B is nothing but this red one. So this red one I will make it ground. I will make it ground. See here, I'm checking 1 0 1. Sum should be 0, carry should be high. Yes, I got sum is 0, carry is high. So this also I have tested. Any other combination on top I will check. I will check 0 0 1 now. 0 0 1. This. So A is 0, B is 0. So B is already 0. CI is high. A I have to make it ground. So A also I am making ground. So see here, I did A ground, B ground, C is high. That means I am checking this 0 0 1. Sum should be high, carry should be 0. 1 minute. I want to make CI high and I will make this ground. So CI is ground, A is ground. Yes. Yes. So I made A is 0, B is 0 and CI is high. I got sum output high, carry output 0. Let me check in the truth table. I made A 0. Let me check. Yes, this green is ground. B is also 0. Yes, this B is my red wire, that is also connected to the ground. And CI should be high. Yes, CI is open over here, that means it acts as a high. And I could see my sum LED is glowing and carry is not glowing. So sum is high and carry is not glowing. That means this is also tested. So in this way, this full adder is work. If I give the 3 binary inputs A, B and CI, it generates this type of outputs as per this truth table. This hardware circuit also we have tested and it is working fine. I hope you have understood this. Thank you.